This video tutorial is for mile marker 2, practice 1, question 3. In question 3 of the mile marker, we are asked to rotate a point, our original point Q, and rotations can be more difficult than some of our other transformations. So let's just break it down to the couple things we need to remember. So first of all, we need to keep in mind that rotations always have a degree and a direction. And the direction is not going to be like right, left, up, or down, but the direction is going to be clockwise or counterclockwise. And I like to abbreviate those. So clockwise, if you just think of the hands on a clock spinning, they're going to always rotate in that direction, and counterclockwise would be the opposite. So all of the mile marker rotations are 90-degree rotations for question 3. So I'm going to show you a trick that only works with 90-degree rotations. So let's read through the problem, and we're actually going to look at two different ways to answer this. So the first one, what are the coordinates of Q prime after Q is rotated 90 degrees counterclockwise? Every time I do a rotation, I still out to the side, somewhere near the problem, write down what direction I'm going to go in. So we said again, we're going counterclockwise. The first way that you might approach this problem is I like to look at the change in X and the change in Y. So I like to look at where Q is from the origin, because the origin is our point of rotation. So if I start at the origin, I'm going over 1, 2, 3, 4 units to the right and down 3 units to get to Q. So the trick that I have for you, and I shouldn't say a trick because it's not a trick. It's still a rotation. What I like to do though is I like to make a right triangle that connects the point that we're trying to rotate to the point of rotation. And again, we said that's going to be the origin. So the next thing that I do is instead of trying to rotate just that point, I rotate the entire triangle. Because what's going to happen is that anything that's on the x-axis, when you rotate it 90 degrees counterclockwise, is going to rotate up to the y-axis. And in fact, if you just look at this part of the x-axis here, if we were to rotate any point on this line, it would end up on this line respectively, the same distance from the origin. So if we do that, it's going to make it really easy to rotate the triangle, which in turn will rotate the point. So again, this part that's on the axis, we're going to rotate that up. So now we're going to count up 1, 2, 3, 4 units. And then if you just kind of look at our triangle, if we imagine what that's going to look like, we're going to go over, 1, 2, 3. So this is where Q prime should be. A couple ways to check ourselves is, one of the ways to check ourselves is to look at the quadrants. If we start in quadrant 4 and we're rotating 90 degrees, it can only end up one quadrant over, so in quadrant 1. So we wouldn't expect for it to end up in quadrant 2 or in quadrant 3. All right, so our coordinates for Q prime are going to be 3, 4. I'm going to show you a second method, and it's my favorite method of 90-degree rotations. I think it's really easy, and a student actually showed it to me last year. So we're back to a blank slate, and we're looking at our original rotation problem in number 3, and we're still rotating 90 degrees counterclockwise. But this time, instead of doing the rotation and then plotting it, we're going to actually rotate our paper. So we're going to rotate the paper, and again, we said it's 90 degrees counterclockwise, and a 90-degree rotation is just going to move the x-axis, here we go. It's going to move the x-axis over into the position that the y-axis is in. We just have to make sure we rotate it in the right direction. So everything moved 90 degrees counterclockwise. So now if you look at where Q is now at the coordinates positive 3, comma, positive 4. And if you remember from about 1 minute ago, that's what we found were the coordinates of Q prime. So we could go ahead and write down that Q prime should be at 3, comma, 4. Oops. Remember to use parentheses there. And then if you're doing a rotation problem like this, I'm rotating the wrong things. If you're doing a rotation problem like this, where you have to mark it, what I would recommend is rotating your paper back and then going over to 3, comma, 4 and plotting your point right there. Well, if I can get that to work. All right. There we go. So there's two methods of rotation, and they both get you the same coordinates for Q prime, which we said is 3, comma, positive 4.